Alright guys, welcome back to Algos Made Simple. We've got Leetcode 54 spiral matrix today, the problem that's short on words but biggest on spirals, I guess. So let's dive right in here and see what we got going on and see what we can get figured out. Given an n by n matrix, return all elements of the matrix in spiral order. So I would let the interviewer know I understand I'm given an n by n matrix that is in a traditional order, and I want to return an output that is the spiraled version of that order. So again, essentially what it says. And if you're not familiar with spiral order, they do a great job in the examples here of letting you know what that is. So you kind of see it. We got 1, 2, 3, and then you're going down from the 3 to 6, 9, 9, 8, 7, 4, 5, and you see how that kind of spirals right there. And you can see with a different matrix right here. So how can we do this? The only way to really figure this out is to look at these examples and look at what they're doing. That's the only way, because you're not going to probably get it from this description. You probably won't get it from seeing this matrix and seeing this right out here, the output. You have to look here and see these arrows and really look at it. If you didn't have these examples, this is something you need to draw out and spend the time to just wrap your head around before you start coding it. So you can see we're going left to right. Okay, makes sense. And then we're going down to the bottom here, and then on this row, on this bottom row, we're going the opposite direction, and then we're trying to go back up top again, but we've already been there, so then we go left to right again. So I would assume a great place to start with this one, and we'll go ahead and fire up our game plan, is we're going to need a while loop with some sort of constraints, because we're going to want to keep going. All right, let's go left, right. All right, done doing that when we hit a boundary or whatever stops us on there. And then, okay, we've done the left, right. Let's go from top down. Okay, in that right column. All right, and we've gone from top down, so down here in the bottom row, let's go right, left. And then let's go from this bottom column, let's go from the bottom up, and then we're back to left, right is what it looks like. So we need to have a while loop that's letting that kind of just keep going, keep making stuff happen. Let's see on this one, left, right, down, right, left, up, left, right. Yep, so we just need something that's going to keep that going. And we also need to have a way that we're not going to run back up this column and hit that 1. So what can we do here? Again, a while loop makes sense. We're obviously going to need a resolution set, so list. And again, this is a great way to do it, guys. When you're in the interview or whatever, write down the stuff you know. Let's get the stuff we know going. So we got a while loop. We know we're going to have a resolution. It makes sense to have boundaries on this thing. So it makes sense to have a left and a right. And it makes sense in this one, because when I hit the bottom, I want to know so then I can go right to left. When I hit the left, I want to know so I can go from the bottom up. So it makes sense that also, in addition to having left and right boundaries, I want to have a top and a bottom. So again, what could those be set to? Well, the left obviously will be 0. It always is. The right will be, in normal circumstances, we're going to use the range probably on this, because we're going to be pulling out these different cells in this. We're going to be probably using the range. So normally you'd set your right to the length. Well, never mind. It's the right for the, well, yeah, normally you'd set it to the length -1 or whatever. But this is going to be the length of the matrix at row 0. So that's going to be your column, basically. And then you got top, which will be initially set to 0 right up here at top. And your bottom will be set to the length of the matrix, how many rows we have. So that makes sense for those boundaries. And then what we're additionally going to do is we're going to need to, once we've hit these boundaries, we're going to need to bring them in, or, bring them in. We're never going to expand them. We're going to bring this in. So we would have the, once we've hit the top, or once we've done the top, we would have the top going increasing by 1, so that would bring it down, and we would have the right going in this way. We'd have the left going in this way, and we'd have the bottom coming up this way, so decreasing in its actual number and coming up this way. Alright, let's see what else we got, if there's anything we can think of right now. Now, I think at this point, you just have to kind of jump in and coding it. And as you can tell, guys, I'm a little bit shakier on this one than I am most of the problems. I've got my head kind of wrapped around it. I've got what I feel is like a pretty simple solution, but it's still one that's a little bit tougher for me conceptually. But let's see if we can get something going here. So going from there, we've got spiral order, and we're passing matrix through. And we said we wanted to have a resolution. We wanted to have our left and right set, these boundaries. Okay. And then we wanted to have our top and bottom set. So we're all good there. Now it's time for this while loop that we talked about. So what will fuel this while loop? Well, if you've done any kind of pointer thing before, sliding window, something along those lines, while left less than right, but we've got a different one in here too, because if this top and this bottom meet, or this top and bottom, if the bottoms are past the top comes past the bottom, that's also a reason to get out and be done with it. So top less than bottom, and what we're going to do is, so now what we have to do, we got to start, it's time to start adding stuff. So we're going to go, like we said, left to right. That's our first step, left to right. So get every I in the top row is what we can call it, get every I in top row. So we'll go for I in range left to right, and then I get us everything up until the right, the outermost, this right that we set is at the length of the matrix instead of length of the matrix minus 1. So what that'll do is that'll allow us to still get everything, because it's going to go, basically our right now is not here, it's out here. So that allows us to grab everything. So for I in range left right, and what we're going to do is simply do res, so our resolution set, dot append matrix, and we want to take the top, which is 0, so our very top row here, and we want to do I. So that I is going to be our left to right, so grabbing those columns at the top and appending it. And then once we've done that, we set on here that once we're done with that top, we need to bring it in. So we're going to do top plus equals 1. Okay, so next step, and just going along with what we talked about, now it's time, we've done left to right, it's time to do this column. So what we'll do is, to get this column, so let's go ahead and put right column, we'll say for I in range, and this will range right here is starting here going down, so it's top to bottom is our range, not left to right, top to bottom. So we'll go top, bottom, and what will happen there is, again, res.append, and we're going to be appending the matrix. This time our I will be for the row, because we're staying in the same column, and our column will be the right minus 1, because again I told you we set our right out here, so our right needs to be brought in to be the correct spot. Alright, so right minus 1 there, and then once we're done with that, the right column here, we've worked on it, now it's time to decrement it. Minus equals 1. Alright, so we're through the top, we're through the right, the next thing to do is to get everything in the bottom row. But one thing we want to check real quick, just to be on the safe side, is if we were to get a situation here where we only had one row or just like one column or something like that, some kind of odd scenario, that would trip us up down here. We wouldn't be able to do it. We wouldn't be able to index what we're trying to index. So we do need to put a little constraint right here and just double check and say this is in case of outlier base case or weird base case, whatever you want to say. We got to check and say if not left less than right. And see, this is what we had at the top here. So we're just checking it again after we've gone through and edited these. So we've already edited the right and we've edited the top. So we're just making one more check before we do the bottom and the left that everything's okay and everything's fine. If that's the case, if it's not the case, actually, I'm sorry, if it's not the case, then we're just going to break and we're done. We're out of here. But if that's not the case, everything's still fine, then it's time to do the bottom row. So bottom row. And what we're going to do, it's bottom row in reverse. So what we'll do here is for I in range, right -1, left -1, and to reverse it, all we need to do is simply put -1. And what we'll do here, you're kind of getting the feel for it. That's the one great thing about matrix problems and just different problems like this, is that it follows a similar pattern once you start rolling. So we'll go res dot append matrix, and it'll be bottom -1 because we've set our bottom boundary out a little bit, and that brings it in. And so that's going to be our row, and then our column where we're going across it is that I we talked about. So the bottom -1 keeps us in that bottom row, and the I is the column. So this part, what we're getting is the easy part. When you're doing your res.append, that's the easy part. If you get tripped up on it, just kind of go up here and look and think about it. What do I need to be grabbing here? Well, I'm at the bottom row, and my columns are going to change over. So that makes sense there. All right, so you get past that, and of course, it's time to decrement it, or increment it, or decrement it, but this time we're decrementing it. Yeah. Anyway, so then we'll go to, once we've done the bottom, now it's time to do the left column that we're at. So we're going up on the left column, or we're going from the bottom up on the left column. So it's going to be another -1 situation. So we're going to say left column's what we're working on now. And we're going to go for I in range, I'm sorry, bottom -1, and it's going to go to the top -1. We're going bottom top, and of course putting a -1, of course we're going the opposite way, so you're going bottom to the top here, bottom top, bottom top. Alright, and then we're going to do just like we've been doing, res.append, and it's going to be, of course, the matrix, and it's going to have I, because the rows are changing. The rows are what we're switching out and messing with. And the left, which is 0 at the time, or the first round through it, is going to be our column. So simple as that on that, and then all we have to do is update the left, and this will be incremented because the left is coming, it's not going out further, it's coming in. Alright, and then finally, after all this, when we're outside of the while loop, we will just return the resolution. So guys, this one is not that daggone bad. It's really, really not. It's just, I think doing the problem a couple times help. I've done this problem a few times just to really try to wrap my head around it and really get comfortable with what I think the simplest code is. And I'm trying to get the game plan down for it, knowing that you need to use those boundaries, the left, right, top, bottom. If you know that, and then you know that, hey, I'm going to have to, of course, append these based on the range. Like if you know how to go through here and go range left to right and then range top to bottom, and you understand the left, right, top, bottom thing, you'll be able to find the rest of this problem. You'll be able to get the rest of this problem together. One thing you need to watch out for is just remembering that once you get through this left, right, I'm sorry, this top right, then you need to double check our constraints again before we do the bottom and left, because we have changed the right and we have changed the top. So we've got to make sure it's not some kind of outlier case. But anyway, thanks for watching, guys. If you've got a simpler way to do this one, or a simpler way to conceptualize it or think about it, please share in the comments. I would love to hear it, and I'm sure others would too. Anyway, thanks so much, guys. We'll be back with another one shortly.